All right, so moving on. So it's unfortunate that we have to deal with all of these complexities, but I mean, it's just the reality, and this is something that we need to by the way, once again, where is my presentation? I want to go back to my presentation right here, right? So we were just looking at the second example, and I will come back to the discussion of the model view controller design or architecture in a little bit. But right now I would like to make some progress through some of our samples here. All right, so in the second sample we just added the panel to the window, as opposed to using or placing our buttons directly on the window. And you could see that there was not a very bad idea. But in addition to the fact that you know, JPanel is if you will, a standard way of handling other components on your form, and it's not unusual to have multiple JPanels on your form. But in addition to this, we also should mention that the JPanel graphical user interface control in itself supports something that generally referred to as double buffer. What double buffer means is this. It's actually a very good thing to have. What double buffering means is that all modifications are made in memory, and then once the modification to your user interface components are finished, only then JPanel will make a real display of that information. Then next, you want to make some modifications to what you're doing inside this JPanel. The modification typically takes place in memory, in the background, and once again, it basically the memory buffers are swapped, and so therefore you have display updates within this JPanel without any flicker, without any artifacts, because sometimes you can see in some applications, some windows create, like, you know, flicker of all kinds when you move that window, or when you try using controls within that, or maybe it has some kind of animation running inside of it. Just remember that typical approach to eliminating those unnecessary artifacts is to organize graphical user interfaces double buffered. Double buffered simply means that updates are happening in memory, and only when all updates are ready, they're becoming visual. Of course, for the user, it's all a matter of, you know, milliseconds. But internally, the difference is big. And if you don't use double buffered style of display, it may be a problem for for flicker and other unnecessary artifacts that may be appearing. By the way, the window, the J-frame compared to JPanel is not double buffered, and so J-frame is not very friendly container for your graphical user interface. Okay, so another reason why you should have JPanel running everything inside your window is this, that it's double buffered, so that it's guaranteeing that the display is going to be smooth and not as to an extent possible, everything is going to look good as opposed to problematic, right? And so we say it's repainted quicker because making updates in memory is a quicker approach, and also smoothly, which is something that you always want. All right, just something to say, something else to say about the JPanel. And so the typical approach is that create a JPanel, number one. Number two, attach this JPanel to JFrame, and then add components to the panel. All right, and that's exactly what we're doing in this demo A2. All right, moving on. Something else. Swing supports something that we refer to as native look and feel. native look and feel may be different inside Windows or Unix environment or Mac, other Apple platforms, different mobile devices. So you want to make sure that perhaps when you create your application, you want to make sure that it's using native operating system user interface. In other words, you don't want to make your Windows look different compared to other Windows on that specific system or platform. So it's what you can do is that you can basically use this user interface manager, which is another utility class within Swing library, where you can say, can you please give me the access to a system look and feel, and first you need to retrieve the class name for the look and feel. Then you have to say user interface manager set look and feel, and you want to set this system look and feel by using this method. Unfortunately, this functionality may not be fully supported, so you have to use like a try and catch method, because it could produce a checked exception, and therefore your code will be a little bit longer than just a single method call. So anyway, I'd say that our next sample here, what it does is it demonstrates that we now add yet another method, which is this system look and feel. So I'll just copy and paste this from here, setting operating system specific look and feel, Control C. So I'm not going to create new project just because I'm still making some small modifications here. I'm just showing you the progression of our demo, right? So here, by the way, I've already made some silly changes here, so I'm just going to use Control Z to undo my changes and go back to the original state. And so here we go. I'm adding this new method to my main class right there. So I'm just going to say source format to make sure that my copy and paste didn't disrupt anything. But this is a very simple type of method. And then also when you compare it with the previous version, simply before even I create my frame, which is the first statement on that event dispatch thread, look what I do. I simply call set system look and feel. So I'm just going to say Control C and copy and paste this to the top of this program where we say create and show graphical user interface. So let's save this and run it. Hopefully it runs properly. So now you see that this became more consistent with what I'm typically using on this desktop right now, right? So my user interface is very much Windows 2000 like interface. It's even more primitive graphical user interface that you would typically find on Windows 7 or Windows 8, right? So I'm using this really primitive, classical old Windows styles. There's no any kind of see-through or anything fancy, and the buttons look kind of ugly but very simple, and so that is the style. And because this is my style, and by the way, I could have changed this style very quickly through my system, control panel and appearance of Windows on this specific instance of Windows 7. Right, and of course, when I call this system look and feel program, it's going to very successfully adapt and blend in to that style. So this is not just my point is that the style of your window is not just the style, generally speaking, supported by the operating system. It also may be the style chosen by the user. The operating system itself could offer user a whole bunch of options to customize the user interface. And if the user does that, and by the way, just like as you see, this is not a standard default interface for Windows 7, but this is what I did on this specific desktop here, and now I'm blending it with my window into that style very effectively, right? So system look and feel is perhaps something that you always want to you can basically roll back and compare it with our initial window that we tried using, and it looked different. So that is basically part of user experience, and perhaps we want this. All right. So that's system look and feel. Very quick, just a very quick look at it. Right here. So once again, because this specific set look and feel may be something unsupported on the specific platform, you have to use try and catch, because it could throw basically this specific swing exception, and we want to handle that. Okay, so that's just something that we need to remember, but it's good to keep it organized and set aside as a separate method in your application, and it's just basically almost like a mandatory step in your preparation to display your graphical user interface.